This call is being recorded.
Good morning, this is Elliot here.
Hi, Elliot.
Hi.
Hello, good morning. This is Holger of Zeiss.
Morning, this is Julian.
Good morning, good morning. Let's give it another minute for more people to join. Right, hi everyone. It's 9:03 and we're already 14 people online, so yeah, that's great. So you saw the email yesterday, Oliver would not be able to host this, so yeah, he asked me to just welcome you here. So we don't have much of an agenda today, so we actually have only one item on the agenda. But before we go into Elliot's presentation on ModMaker, does anyone have any news that they want to share or anything about our wonderful initiatives and what we're doing? Can anyone hear me?
Yes, we could hear you and appreciate that you're taking over this moderation. So,
Thanks, Francis. Yeah. So, right, then I see no news. The only local news here is that Oktoberfest is cancelled for the first time since the 40s. So, yep, okay. We're in it for a while. Right, so nothing else for me to say. Elliot, the floor is yours.
Okay, thank you. Good morning. My name is Elliot Lear. I work for Cisco Systems. I noticed that we're actually an OpenChain project member, but I didn't know that coming in, actually. For this project, I was approached by some people on related projects, and we put together with Oliver and other people to talk about OpenChain as relates to software bills of material. Now, by way of background, I'm a network guy through and through. I'm also a bit of a scaredy cat when it comes to IoT and security. And so that is the two motivating factors of my work, which is to try and protect IoT devices. And I can see that in that respect, OpenChain Project and the work that I'm going to present to you are entirely aligned. Now, my understanding of OpenChain Project is extremely limited. And therefore, given that we don't have a huge crowd on the call here, I would ask that you interject at any time to either correct misunderstandings I have or to ask any questions you might have along the way. Now, what I'm going to present to you, assuming I am able to do so, are, I see I have a little problem already, which is I was going to share my screen, but I'm coming through on the browser version of this, and it appears I will have to rejoin the conference call in order to do the presentation. But while I am in the process of doing that, let me tell you a little bit about manufacturer usage descriptions. Manufacturer usage descriptions are an attempt to address a particular problem, which is what sort of access does this device need of the network, and it can also answer a different question, which is what sort of needs of the network does this device have? So those are the two questions that that MUD attempts to answer. And just by proof of the way that I'm an engineer, only an engineer would name something that has an acronym called MUD. With that, let me try to get into the conference. Just to give me a moment and see if I can do that. Oh, yeah. Let's try this here and see if that works. Yeah, just a moment. Or did I go to the wrong place here? Just a sec. Oh, I see, okay. It seems I'm in the right place. Oh, no. I apologize for this delay. I'm just having a bit of a moment getting in. And if you'll excuse me for just a moment, I will rejoin the conference from in a way that can be in a way I can present. So please excuse me for just a moment.
Sure.
It appears, if you'll please forgive me, I have to rejoin one more time. I apologize. I'll be right back. Okay, so I am attempting to now share my screen. And let's see here. Let's try that.
Perfect.
Okay. So, oops, I bet you're looking at the wrong screen. How about that? Good?
Great.
Okay. So, just to give you a sort of background of why I did this, as I mentioned, it's try to understand the network needs of devices. I just have a question for the people in the room, so to speak. Would anybody care to guess what sort of network access that printer requires? Okay. I realize we're on a conference call. It's sort of hard to decide whether people are unmuting, but in any case, you would be wise not to guess, because this is an example of just one printer. You'll notice that we've collected a bunch of information. This is an HP printer, and it uses all sorts of network access.
Elliot, we're still looking at the title slide.
You're still looking at the title slide.
On not on presentation, on the
Has it moved forward yet?
Yes, now I see what sort of access to this is required.
Okay, it seems as though presentation mode doesn't work with this, this conference on the Mac, so I'll just go forward without it. Basically, the way that we try to solve this problem is that we want the device to articulate to the network what sort of access it needs. And this is the notion of manufacturer usage descriptions. And it consists of 4 components. And I'll talk a little bit about how these relate to what I think are the OpenChain Project goals in a little bit. The first is a URL that actually gets announced by the device. The second is a file that the URL points to. And this is where we'll spend a little bit of time. A third is a component within the network to provide to capture that URL and provide that information to the network administrator. And the fourth is a server that hosts the file that is retrieved by this server. I'm not going to go into all of the mechanics of MUD today, in part because I don't know that it's entirely relevant to the discussion, but I'm always happy to answer questions about it. So let me take a brief moment or two. I'm sure that Alan has presented to this group, Alan Friedman has presented to this group, or somebody has presented to this group on what a software bill of material is. A software bill of materials, simply put, is an inventory of software on a particular device or in a particular package. So it's a bit of a recursive object. That is to say, a software bill of materials itself can contain many software bills of materials. It's intended for two target groups in that respect. The first is developers who are making use of components and want to know what those components themselves are actually using, and there are two major uses of SBOMs. One is just making sure that you're licensing compliant, which I know that is an area that the OpenChain project is interested in. And of course, I'm sure you're also interested in the aspect of cybersecurity. The second target user group are end customers. And so this is the area in which MUD in particular overlaps. And so MUD focuses on somewhat the very end of the supply chain. That is to say, the final delivery to the customer by the manufacturer, usually in the last steps, and when the customer plugs in a device. One of the areas that we'll talk about a little bit is that in order for MUD to function at all, it needs the developers need to do a little bit of work, both in terms of announcing the URL that I mentioned before and building out the file that I mentioned before, and that's where we'll do a little demo. So just a very brief view of this. The device outputs that MUD URL. This is where that capture occurs, gets passed to this thing called the MUD manager, which other people might call a AAA server or policy server or DHCP server. It goes and retrieves this meta policy, if you will, and then determines the appropriate access for a device on the network. It can also do other things like pass up additional information to other components of the network, and that's where we'll spend a little bit of time. The MUD files themselves are generally signed and are basically JSON files that adhere to a schema that talk about access controls, but not just access controls, and I'll come back to that. And the file gets interpreted. An administrator may review it, approve it, reject it, amend it, or do whatever, and then policy gets translated into configuration, and the device is given the appropriate access. And so the whole point of this is to microsegment devices. IoT devices in particular have a challenge, which is and a benefit, which is really they only need access to a small handful of devices out of the some 17 billion devices that are connected today. And so if we're able to enumerate those devices, all the other devices who are potential threats to that device, we can block the access to those guys, even if they're directly connected to the same network. And we can do this, pretty much any network vendor can do this, in fact. So this is actually what I'm talking about is an IETF standard that a number of implementations have been built up upon. So,
Elliot,
mm-hmm.
Sorry, if I may interrupt. So the device is sending the access that it wants, right? Is it all being accepted or rejected as a whole, or each item in there can be, accepted or rejected?
I'll answer the last question in reverse. The administrator gets the final say always as to what sort of access the device gets. The device manufacturer can only provide a recommendation, and the circumstances for any given deployment may vary. And how you might want to interpret the information that you're receiving from the manufacturer in terms of the sort of access control mechanisms you use will vary as well. And the device itself, at least in the current form, doesn't actually share access lists directly. It just shares a URL. And the presumption here is that it's going to use an existing interface like DHCP or LLDP, or the URL will be in a certificate, which can be transmitted up. And it's this guy here who then goes and retrieves the actual access list recommendations, and then the administrator then gets to interpret them. Does that answer your question?
Yeah, sure. Thanks.
So are there other questions before I continue? I realize I'm dumping a whole lot at once here. People. Okay. So now the question is, well, what happens? What happens with organizations that want to retrieve a software bill of materials for this device? And so why would they want to do that? Software bills of materials will indicate, again, what packages are installed on a device. And the reason an enterprise administrator might want that information is to understand his or her exposure in terms of vulnerabilities that are in particular pieces of software. And the idea is to get to time to remediation as quickly as possible. And how might an administrator remediate any vulnerabilities? One of the ways that that he or she should first do so is by providing microsegmentation. And so there's a bit of a natural affinity between software bills of material and manufacturer usage descriptions. But one of the key aspects that the SBOM people have suffered is that they don't really, they haven't had a means to identify the appropriate software bill of material with a particular device. So how do they go find the software bill of material for a device? And that's an area where I've spent some time working. And so I'm going to now try and just share with you a different, let's see here. Let me stop sharing just a moment. How do I do that? Here we click stop share. And now we share again. And we will share. Can you see the screen that says welcome to ModMaker?
Yes.
Okay, very good. We're dealing, we, the networking industry people, are obviously dealing with, in the IoT space, with people who are excellent in terms of their domain of expertise. So if they know how to build an oven, they probably understand the ability to design a thermostat really well, to design a heating element really well, and to safeguard the device from fire and such. We assume that they have very little time, though, to deal with security, so we built in a fair amount of tooling for IoT developers, and this is where ModMaker comes into play. It comes with ability to visualize the access that you are proposing for a device, and then to write out the file for you and even provide an example signature for that file. So, and this is just an example of the tool. I'll step you through. So if suppose we're talking about a coffee maker, that is going to have, say, Mr. Coffee Model 2000. And this is, we'll say Mr. Coffee here, which is a common coffee maker brand from the 1970s and 80s in the United States, but now they're IoT enabled. And so one can add a little bit of documentation here. And this is a coffee maker, for example. I'll come back to the software bill of materials in just a moment. Many devices have a usage pattern that they go out to the cloud. As we get in, I'm sure OpenChain Project is looking at cloud-related componentry, and this is an area where device meets the cloud. So one of the types of communications that a MUD-enabled device can articulate its need to the network for is just that, cloud-enabled. So we use that as an example. And just to give you an idea of what might be going on is that the coffee maker might page you when the coffee is complete, and then the way that it's working is that you've registered your cell phone number on the back end of mrcoffee.example.com. And being the internet geek that I am, I always like to believe that the world will be going to IPv6 real soon now, right? But MUD supports pretty much anything. In fact, we're looking at support for MUD without IP at all. So we might say that this is cloud connector.example.com, and maybe the Mr. Coffee application even understands TLS or something like that. If I'm speaking a language that you don't understand, please stop me. I'm obviously in a new room. I'm happy to back up and talk at obviously different levels. The result of this is a file. that talks about the access, right? So it's just a JSON file, and if you're familiar with networking devices, here's the basis of an access list. We've just added a component here, which is to make a domain-based access list. And here's a way to scan in that information if you can't have the device itself directly output the information. So this is just a device with access. Well, now let's back up and review our example. And let's say that there is a software bill of materials for this device that, and it's the device itself isn't going to give that information out. You have to refer to it by a cloud, or maybe the device will give the information out, or maybe you have to call the manufacturer to get the file, the software bill of materials manually, or maybe you have to send the manufacturer email. So in this case, we'll just say that MrCoffee.com has that information. Maybe it's separated by version numbers, right? And then you might have a software bill of materials. And so all of a sudden, when we click submit again, right, we'll see a new component here, which is just this SBOM information that says, here's where you can collect information about what is running on the device. So this is what ModMaker is about, and this is what MUD is. MUD is a way for device manufacturers to describe their devices to deployments when they wish to do so, and when the deployments wish to see that information. And so this is the standard. It's in the internet. It's an RFC, request for comments, RFC 8520. And the NIST, the National Institutes of Standards and Technology in the United States, has a series of best practice guides on how to use manufacturer usage descriptions as part of secure IoT onboarding. And so now you may ask, okay, what does this have to do with OpenChain Project? First of all, I will turn that question around in a little while and ask you, as I'm the newcomer, and I don't want to be too presumptuous, but one area that I know I need help on is that many times manufacturers do not know what sort of network access their devices need. They don't know how to answer these questions directly, and they need for the software developers to help them out. And so one thing that we're pondering is, should software developers provide snippets of these MUD files that says, okay, I'm offering an HTTP server, for instance, in my product. Maybe I should offer a little bit of not only an SBOM for that server, but also maybe a little bit of a snippet of an access list that will need to be implemented in order for this product to function properly. And MUD provides the means to describe that. And as I understand it, and please correct me if I'm wrong, one of the areas where OpenChain comes in is certifying the suitability of software for the supply chain, and perhaps part of that suitability is having appropriate best practices around cybersecurity and limiting the exposure of a particular component to just those devices that are and services that are authorized to it. Seems to me a pretty good best practice at this point, or at least being able to describe what those services are. So that is MUD and ModMaker in a nutshell. Do people have questions or comments either about ModMaker or about software bills of material? I can only answer some of the SBOM questions. I won't claim to answer all of them or many of them authoritatively, but I can answer some. Then let me turn the questions around, which is, do people have a feel for the value of either software bills of material or manufacturer usage descriptions as relates to both the OpenChain project and towards the end of the supply chain in particular? And that's question number one, and I'll stop sharing. I hope people don't mind me sending video. If they do, I'll turn it off. Can people still hear me?
Yes, we are. We're a very quiet group today.
Yeah. So that leads me to believe that perhaps I came in from outer space, and maybe the relevance of this work isn't particularly clear.
So OpenChain tries to, be a general solution for the whole supply chain, right? And the information being included in every step is still up to determination, right? So we definitely, I mean, when we started OpenChain years ago, we were definitely more interested in the beginning about licensing information because that was the legal risk. But obviously, as you already mentioned, security is taking more and more prominent role in the discussions, and from today's presentation, access control would also be coming up in the line.
Okay, so there definitely are different levels at which this can we can think about this. So if we think about this from a software standpoint, just a software standpoint, the rules associated with a particular piece of software can be derived. In fact, there's a company in Canada and Israel that is actually doing the code analysis to produce these sorts of snippets, for instance. So they're interested in that aspect. And if people are interested in learning more about that company, I could refer them to you, Alexios, or to Olivier. The second part is when we're talking about more of a physical device component that's already built and being integrated. At that point, if the integration is taking place in a networked environment in particular, then a MUD file is a very useful thing to have. It says, okay, here's the, we can build up an entire, we can explain, okay, this device is being used in an industrial environment. It wants to talk to an HMI, and it wants to talk to maybe one or two other reporting systems. So those are some ways that I could envision OpenChain project interacting with this. And then, of course, there's MUD, and then there's SBOMs. And of course, I think the OpenChain project has taken some interest, at least in the latter, and is just now hearing about the former. Any comments or thoughts? Okay, well then, given that we don't seem to have a lot of discussion, let me just say, if you would like more information on manufacturer usage descriptions, just feel free to email me, lear@cisco.com. Feel free to try the tool that I pointed to. It's modmaker.org/SBOM. The SBOM version is more of a prototype than the rest of it, but not far behind. I'm happy to answer any questions either now, later, or whenever you have them. And thanks for your time today.
Thank you.
Thank you very much.
Yeah, thank you very much. Are you going to give this presentation tonight at 6 again, or not?
Yes, I've been asked to do so, and we'll be happy.
All right. I missed a little bit myself for technical reasons, so I'll be happy to join again. Thanks.
Thank you.
So Any other question for Elliot or any other discussion for the whole group at all, or shall we close the call earlier? We are definitely a silent group today. Yeah.
No other points.
Okay. So, okay, hearing nothing. Let's close the call. The next one will be in 2 weeks from now, which is, let's see, the 6th of May. Hopefully Oliver will be back by then. Thanks, everyone. And yeah, we're gaining 25 minutes to work on other stuff.
Thanks, Alexios. Thanks
Okay.
all.
Thank
Thank you
you
very much.
Okay, bye.
Bye-bye.
Take care.